Hello, algebra students. We're going to do 11.6 today. Radical expressions. They're just radical. So, in math world, what does radical really mean? Well, it is another reference for the square root sign. It's called the radical. Okay. And the whatever's in there is called the radicand. Okay? So we are going to talk a lot about how to work with these radicals, how to simplify what is legal and what is illegal, or illegal, I guess would be the proper way. So when you're working with multiplication and division, you can break things down much easier. But when you see adding and subtracting in there, then things get a little more difficult. So I'll run through quite a host of examples here, and again, feel free to rewatch them. You know, if you hit one like it in the book and you can't remember, oh shoot, how did Mrs. Silva do that? Go back and look. Or look at your note sheet that you're going to do right now. All right, so when you look at 2 over 50, the fraction 2 over 50 reduces down, doesn't it? You can divide both of those by 2, and you're going to end up with the square root of 1 over 25. Well, here is where it will split up. So the square root of 1 over 25 will break down. You can write this radical at the top and the bottom. So I can rewrite this like that. That's the exact same thing. And now the square root of 1 is 1, and the square root of 25 is 5, and we are done. So those are some of the simpler ways to do these. Now we come to something like this and we can't say, oh, a square root and a square, they cancel each other out. I can just cross these off and I can cross this off and I'm done. No, because of that plus sign. Otherwise, actually, you could do that. So what we're going to have to do is go ahead and square these out. So 8 squared is 64 plus 15 squared, which is 225. And we're going to add those together. And we get the square root of 289, which comes out nice and even to 17. Okay, so those are when they're numbers being added. But sometimes you'll have these variables, and I'm hoping that if you didn't see that square root there, this middle part should look familiar to you because we did a lot of work with those, didn't we? Those are quadratics, and we talked a lot about how to factor quadratics down. So we looked for two numbers that add to give you a -6, but will multiply to give you a 9. How about a -3 and a -3? That's right. So we have x minus 3 times x minus 3. Because remember, we use those numbers. And you might look at that and go, okay, but that doesn't really do much for me right there. But if I have a 3 times a 3, isn't that the same as a 3 to the second power? So if I have x minus 3 times an x minus 3, that is the same as an x minus 3 to the second power, isn't it? Ah, and now that I have this 2 on the outside of the parenthesis, see over here, it wasn't a parenthesis with the 2 on the outside. It was in these separate things that were being added. But here it is on the outside, so this square root can cancel with the square. And you are left with, and it has to be positive, so I'm putting an absolute value around it because you can't have a negative in there, at least in the real world. So it's the absolute value of x minus 3, and that's that. So it's a lot simpler than this. And that's what we're trying to do, is we're trying to simplify them. We're trying to break them down so they look a little nicer. This looks nicer. This looks nicer. This looks nicer. Okay? So now, again, we're going to simplify, and we don't have any kind of fractions in here. This one just straight has a number. But you can simplify that down by thinking about a number that is a perfect square. And let's just refresh what a perfect square is. Well, a perfect square is what you get when you square 1. 1. Or when you square 2. 4. Or when you square 3. 9. Or when you square 4, 16. Or when you square 5, 25. Or when you square 6, 36. Or when you square 7, 49. Or when you square 8, 64. Or when you square 9, 81. So those are all wonderful, perfect squares. Okay, so now that we've reviewed all of those, we can think, are any of those factors of 24? 1, 4, 9, 16, 25, any of those? Sure, the 4 is. So watch how we're going to do this. We're going to rewrite this as 2 square roots, where one of them is going to be one of these circled numbers. So I'm going to do the 4. I'm going to put it first. So you can feel free to write the circled numbers if you're having trouble next to on a note sheet somewhere, a note card. And then what would equal it? So 4 times 6 is 24. So square root of 4 then is what? 2. And that's why we picked it. I could have put 2 and 12, but that doesn't help me because when I take the square root of 2 over the square root of 12, it doesn't come out even, or not even, whole like this. Okay? So that's why we specifically picked this combination, because one of them was a perfect square. And that is as far down as that one can go, and we're all set. All right, so I have somebody cleaning the bathroom right now. Anyway, let's do this with variables. When we have x to the third and y to the fourth. Remember, this is a square root, and we don't put the little 2 there, but there is a 2 there. So whenever there's an even number here, it will cancel out, and you're basically dividing these out. So in other words, when I see that y to the 4, what is 4 divided by 2? 2. So the square root of y to the 4th is actually y squared. Okay, 4 divided by the 2. Now this gets a little trickier because we're looking for the square root of x to the third. So one of these will factor out, right? Here you had 2 sets of 2. But how many sets of 2 are in here? Just 1. So I'm going to put the x here. And then if I take out a set of 2, how many are left in there? I'm just going to have the 1. So I have to leave the x. I don't want that to be confusing, so I'm going to actually erase that. That is what your final answer is going to look like. I was able to take 2 pairs, or 2 of these out, because remember you take them up, think of it like a pair. So every y squared means I can take out 1. So I've got 2 sets of y squared. So I had 2 pairs I could pull out. But I only have 1 set of 2 in there. So I pulled out 1, and then I had 1 still left inside. That'll come. I know it's a little tricky to wrap your head around at first. All right, this is what we've got left to go through. So let's simplify again. So when we have the square root of 5/4, the problem is also you can't, and I didn't mention that up here because it didn't come up, because the square root of 25 reduced to 5. But you can't have a square root in the denominator. You can't have it in the bottom, or it is not simplified. So I'm going to explain to you right now how you can get rid of that, because you can break this down like we did up above and do this. Oh, and actually that does come out nice. Sometimes the bottom number doesn't. Okay, so we have the square root of 5. That can't be reduced, but the square root of 4 is 2. So we're all set. The problem would be if there was a square root still in the bottom, and I'll get to that and show you, I think yet today. Let's see what this next one yields. So let's break this down. Square root of m to the third over square root of 9m. Now when you have these two things multiplied in here, we can also break those down. Okay, so this down here is the same as square root of 9 and square root of m. Same thing, because it's multiplied. Okay, you can't do that when you're adding, only when it's multiplied. So in the bottom, square root of 9 is 3, and square root of m I can't do anything with. And what happens up here? How many sets of 2 are in here? 1. So I will pull out an m to the 1. And then there's something still left, isn't there? I pulled out a set of 2, so I have 1 left. And you don't have to put the 1 there, but just to show you. Look at this, class. Square root of n over square root of m cancels off, and we're left with this. So I still haven't gotten to show you what happens. That might come up in another lesson. Let's take a look at this one. Square root of 108 over the square root of 25. All right, well, the bottom's lovely. That's the square root, that is just 5, isn't it? So we got the bottom all set. The top we got to think a little more about. So if we have the square root of 108, we got to look down here and think, are there 2 values, and is one of them a perfect square? So go up here, look at these circled numbers. Are any of them a factor of 108? I know, but if you didn't know, you would be up there going, okay, I'm going to try 36. Wow, it worked. That's so great. So I have 3 and 36. Remember, one of these needs to be these circled values that if you don't know them, you should write them down. Now, what's the square root of 36? It is 6. And you're left with the square root of 3 because that does not simplify down any further. And I can write these in either order because we are multiplying. So the proper way to write them is to put the whole number in front and then the square root. Done. All right, the next one, break down. So we get I'm hoping you can see some of this is going to turn out nice, isn't it? This top number, because these are multiplied, I can rewrite that as square root of 9 and square root of x cubed. Okay, so square root of 9, nice. Comes out to 3. I'm just going to leave this like that for now. We still have a little work to do. And square root of 16 is 4. But how many pairs can we pull out? There's 3. A pair means 2. We can pull out 1 pair. So I'm going to take out 1. And what's inside? We still have a 1 left if I've taken out 2. And we are done with that. All right, so our last one is our wonderful word problems. A quadrangle. You don't hear that too often, do you? On a college campus is a square with sides of 250 feet. So, as usual, we draw pictures when we need to. So I'm going to draw my square. If a student takes a shortcut by walking, there they are, diagonally across the quadrangle, and now they end up over here. How far do they walk? So we're looking for that distance. Give the answer as a radical expression. You know what radical means? It means this right here. It means you didn't take square root of 5 and put it in your calculator and divide by 2 and get some rounded off decimal. It means the radical is still there. Okay? In simplest form, which is what we just talked about above, having it reduced down. And then it says to estimate the length to the nearest tenth of a foot. Okay, so do you guys remember, if we have a square, we have right angles, don't we? Do you remember how we figure out the third side if we're given 2 of the 3 sides of a right triangle? It's Pythagorean theorem. Did you guys say Pythagorean theorem? You are right. So it's a squared plus b squared equals c squared. A and b are the legs. So we have 250 squared plus 250 squared equals we'll call it x here. So we can go ahead and okay, so 250 squared, 62,500 plus 62,500 equals x squared. Add them together, we get 125,000 equals x squared. And then, to solve again, we need to do square root on both sides. And break it down, because we need to have the simplified version. So I am going to look here and see 62,500. Nice. Okay. So 62, we can also write this as square root of 2 times square root of 62,500, can't we? So square root of 2 does not reduce, but guess what, guys? Square root of 62,500 does. It's 250. So this is a tough one. You might have to play around a little bit with this number to try to find a perfect square, but that's half the fun, isn't it? So there is our reduced, don't forget the feet. And now it asks for the nearest tenth of a foot, so I will multiply that by 2 root equals, right there, can you see it? So nearest tenth would be right here. The number after it is a 5 or bigger, so that number needs to jump up. So 353.6 feet. All right. So I hope that helps. Feel free to re-listen to anything that gave you any trouble. Have a great day. God bless.